This is problem 1 on practice exam 5 of chapter 2 in the book Problem Solving with Differential and Integral Calculus. It involves a bank account deposit of $10,000 on January 1st, 1980. It has interest that is compounded continuously, that is all the time. Every dt, they recalculate the interest. So there's the growth of the bank account. After 25 years, it goes from $10,000 to about $21,000. Part A, estimate the change in the bank account value dB in the infinitesimal time dt at midnight, January 1st, 1980. Let's focus on that one. What is dB at midnight, the day after it was deposited? We're not told when it was made, but doesn't matter, because the slope of this line, it looks like from 0 to 1 year, it's pretty constant. So whether it was 10 hours, 8 hours, doesn't matter. We need the initial growth rate. We can just draw a tangent line at t equals 0 to get the initial growth rate. There it is. That's a pretty good tangent line. You can see it doesn't peel away from the actual line until 3 or 4 years. So the rise looks like it's 8,000. Be careful. This y value is 18,000, but it started at 10. So the rise goes from 10,000 to 18,000, which is 8,000. The run goes from 0 to 25, the entire range of the horizontal axis. That's a growth rate of $250, $320 per year. So we can solve this for dB to get the change in the bank account value. It's the rate, $320 per year, times dt. It's a function of dt. So on to part B. Estimate the amount of interest earned over the first 24 hours after it was deposited. We know the growth rate. It's $320 per year. That connects dB and dt. The delta t is 24 hours, which is 1/365th of a year. We plug that in for dt. Don't tell any mathematicians we did that. It's an approximation. The change in the bankroll value is 89 cents. And I'm happy with that. The account earned 89 cents of interest the first 24 hours after it was deposited. On to part C. Starting at midnight, January 1st, 2000. That's 20 years after it was deposited, right about here. Estimate the time it takes for the bankroll to increase by 10 cents. So here we're given the rise. The rise is 10 cents. How far do we have to go over to get a rise of 10 cents? So we need the growth rate. It's not $320 a year anymore. We have to measure the growth rate again. It's significantly higher. So there's the point, 20 years. Now we need a good tangent line. There it is. The rise looks like 10,000 to 21,000. The run goes from 5 to 25. That's 20 years. So now the growth rate's $550 a year because, of course, it's got a lot more money in the account now because it earned a lot of interest. We can solve this equation for delta t. We have delta b over delta t is $550 per year. We want to know what delta t is for delta b of 10 cents. So we plug in 10 cents for delta b, and we get this. I don't know what that is. My intuition is not good for 0.000182 years. Let's convert this to something we recognize. So multiply by 1, multiply by 1 again. A fraction is equal to 1 if the top is the same as the bottom. So I took this time and I multiplied by 1 twice. And it's the same time because I multiplied by 1. It's just expressed in different units. 1.6 hours, that's less than minimum wage, but no one's actually working, and your money's working 24/7. It's compounded continuously all the time. On to part D, estimate the time it will take until the bankroll is growing by $500 a year. So it starts off $320 a year. So here we're given the rate. The rate is $500 per year. At what time is that the rate? So the slope we need is $500 per year. How can we get a slope of $500 per year? Well, if we go from 0 to 20, if we have a run of 20 years, and we have a rise of 10,000, that's the slope. Here it is. A rise of 10,000 and a run of 20 years. So the run goes from 5 to 25, the rise goes from 10 to 20. And if we draw a straight line, that's the slope we need. So there it is. And what we do is we just move it over. We translate it without tilting it, without changing the slope. We translate it until it touches the line. So we just keep going in, and there it is. And we can drop a vertical. Looks like 17 years before it's growing at $500 a year. That's problem 1.